It's time to get started again. Our final speaker this morning is Dr. Paranthaman. He's ORNL Corporate Fellow, Group Leader of Material Chemistry at the Chemical Sciences Division, graduate from the Indian Institute of Technology in Madras. So please welcome Dr. Paranthaman.
Thank you. So I come from a totally different background, and I've been doing science for the last 25 years at Oak Ridge. Pretty much, if you want to ask any question about energy, either production, storage, or transmission, I worked on all these areas at Oak Ridge. I was very fortunate. So my colleagues already, both of them talked about different things, and it's totally different right now. I'm going to show some example, and as you can see the title, so I want to talk about rubber meets the road. So that means I'm going to talk about more tires. What are we doing with the car tires mainly? So that's what I just did. So I have done like so many discoveries at the lab, and I'm just touching only one example today. And if you have any questions, I'll be happy to answer. So first, so it's always Department of Energy, so they always fund us. So we are very fortunate. So one thing I want to always talk about, dream big. So you have to dream big. That's what I did, and I'm going to show how I did, and I'm very fortunate. So the other thing is you need to work hard. So if you see the map, so I come from India, so you can see all the way from the Asia into all the way to Tennessee. So first I came to Texas, so we'll see the things, what I did like almost 30 years ago. So my father went to college, but he never graduated. But I finished undergraduate, master's, PhD, and right now I am one of the top scientists at Oak Ridge National Lab. So I could do only because of hard work, focus, and I worked on different technology, and we'll see how I did. And you have to be really dedicated, focused in your life. So one thing, my journey, it started from a small town from India. So I'll just show that. It's not easy, but focusing on the passion for research. So I have great passion for research. I'm a real scientist you can meet. That's what I can define myself. So the thing is, it's very easy, but I have made my dream into a reality. So that's what we are going to talk about. So I'll give few examples and how you could do what you could do. And we already, Marisa touched on, and Dr. Smith touched on all these things. So if you look at my footstep, like I started from India, like a small town, and you know a couple of things always, India is a big country, and two things we always keep in mind right now, if you want to be a vegetarian food, and also yoga. These two things caught on really big right now in the whole world. We are all following all those things. Then from there, I went to IIT. This is the Indian Institute of Technology. This is one of the top schools in India. It's a #1 college in India. So the world ranking, probably they are behind. So I was very fortunate. So I had so many good mentors. Professor Rao, who was a really mentor, he mentored me when I was in India. Then from there, I came to Texas almost 30 years ago, 1988. I moved to Texas, Austin, Texas, and I did my material science, worked with Professor John Goodenough. So John Goodenough is 95. He's still working, he's still driving, going to work and coming back. And the last 3 years, he was all in the very short list for Nobel Prize, and I'm hoping this year he will make it. So I have really worked with him, published 15 papers. So he's the inventor of Lithium Ion Battery. So I'm going to talk about some other batteries. So we all use every day, every one of you, either you have either a cell phone or iPad or laptop. So one of these you will be using, and batteries are the key. So I will just give you some example what you do and what is a battery and talk about that. Then from Austin, I went to Colorado Boulder. So 1991 I went, and I was in the physics department again. So the timing, I don't know, after I left, they have won 3 Nobel Prizes for physics in University of Colorado Boulder. So it's like I always had different mentors, Professor Herman, superconductivity I worked on. Then I came here in 1993, so I joined ORISE as a postdoctoral fellowship. Then after a year or two, then I became a staff. So I've been at the lab for 25 years. So now I am at the Oak Ridge. It's really the premier laboratory, and you need to focus hard, and I'll talk about some examples what you can do. So one thing, you need to have a goal. I said dream big. So you need to have a vision, what you want to do in life. So everybody, one thing I always mentor is, you are good at something. Everybody is good at something. You need to find what you are good, and you need to be the best in the world. We cannot just think Tennessee. We cannot think United States. We need to think globally. We want to be the best in the world. That's what you have to think big. Whatever it is, for example, like innovation, discovery, and commercialization. So I have taken 7 technologies from the science lab, what I do in my lab, into the commercial market. So I am a unique person at Oak Ridge. So that's what you have to find, the uniqueness, what you are good at, and pursue the career and go. And you need to be a role model. So it doesn't matter who it is, how your background, all those things. You have to be a role model. That's what you have to be, the leader. And again, you need to have self-discipline. So things, internet, we see everything online. So whatever you do today, 30 years from now, you may become the president. It will come and haunt you, what you did 30 years ago in Oak Ridge around Tennessee. So things, you need to be self-disciplined from today, so that when you become a president, you be the best president what we have. So that's what we want. Another thing is, already Dr. Marisa touched on, you need to be positive and confident. So you need to ignore all the negative thoughts, views, and people. So these are really important. I follow very carefully all of these things. That's what I do. And the other thing is mentoring. One thing is, you can become a mentee, and I have had so many good mentors throughout my life, professors, right from my school, college, and now. And now I have been mentoring like a lot of undergraduate interns. More than 150 students have worked with me in the first 10 years. So there are a lot of opportunities. Even as a high school, you can come and work at Oak Ridge. They do a lot of programs at the manufacturing demonstration facility. Once you graduate from high school, you can come and work in undergraduate, graduate school. So I am a Bredesen Center faculty, the one Dr. Marisa talked about. So we do mentor students coming from University of Tennessee. They graduate. One of my recent students, he worked for Apple. So things like, we send them to the top places in the country. So there is a really good opportunity, and the learning never stops. So I'm learning every day. So you need to think about your life, what you want to, how you want to advance your life. So you need to be positive. You need to have a good mentor, self-discipline, and also a role model, and you need to pursue your goal. So these are the things I did. Then let's get into what we are doing is. So the tires. So if you take really car tires, the tire contains 3 or 4 kinds of rubber. It's a polymer, mainly rubber. Then what they do is, they add carbon black. Carbon is really added. Carbon is black powder. So you can see I have some carbon powder. So we have this recovered from the tires. So they just add, that's why the car tires are black, to get the mechanical properties, and they do a lot of organic fillers and additives. So you have different kinds of tires, passenger tires, and different automobile, different things are there. But all of them may have a different variation, so they add different strength. It can last long and all those things. So what's happening is, 1 billion tires every year globally is being wasted right now, 1 billion. And just in US alone, we have 300 million tires. Whether you like it or not, 300 million tires are waste are generated every year. And we are not doing any recycling at all. It's really shame. So we are doing less than 10% of the world recycling tire. Because the tires is, when you want to change your car tires, you are actually paying. You have to pay $1 or $2 to change your tires. Because that's what they always charge. When you buy a new tire, you have to pay a few dollars to get rid of your old tires. But we are not recycling. We have been just using the crumb rubber simply for road fill and doing some engineering application. So until like 4 years ago, another scientist colleague of mine, Amit Naskar, and I, we came up with a process. What we did was, we take this crumb rubber, you just take a real waste tires. So this is, we are talking your tires. waste tires, you just cut it into small pieces. So you can dip it in sulfuric acid, simple sulfuric acid. As a chemist, you just dip it in sulfuric acid. It forms like sulfonated rubber. Then you cook it in a furnace. So that's what we are doing. So you just dip it in acid. It's a simple magic. You just cook it in acid and bake it in, and then you get carbon. So you can actually recover up to 58% of carbon. So imagine what we want to do is we have developed this technology and we want to use it for high value added product. So things like Michelin, Goodyear, a lot of big company, tire company, they are coming back. Can we put this carbon back into the tires? So we want to recycle the tires or produce recycled tires. So only they have been able to put 10%. So they want to put more into the tires. So the other thing is, with this application, so we have come up with so many applications, energy storage. Simple example is carbon is used as an electrode in one of the lithium-ion batteries we'll touch on. So we licensed to a company, they are trying to scale up right now. So you can have, imagine, in every county, every town, every city, every place, so we can duplicate this whole effort and we can be recycling these tires for different applications. So let's see. So if you take a tire, you can recycle, you can get like gas, oil, plus this carbon. So this polymer is coming as oil. So first thing what we did was we made lithium-ion batteries. So I'll talk about lithium-ion batteries in the next view graph. So you can actually take the carbon powder, use it as one of the electrodes, then use it as a battery material. We have already demonstrated, and I have some coin cells to show you batteries, so one application. And the other one, we made even sodium-ion battery, potassium-ion battery, or a supercapacitor. So there are a lot of energy storage applications. So you can use for the grid. So if you want to have a solar and a wind energy, whatever you're generating from wind and solar, you can store it using one of these batteries. So imagine you can be self-sustained. So you can produce your own energy, store it in, use it when there is no light, when there is no wind, you can use the energy back in your house. So that's a technology. Again, we are using different things. And very recently what we did was, one is we are talking about waste tires. Another one is waste cooking oil. If you really know what you are doing is, we are not doing anything at all. After you cook oil, or if you do any of these fast food restaurants, we are doing frying everything, French fries, all the things, but we are not recycling. Imagine if you collect all this waste cooking oil. So this is from my house. This is a real waste cooking oil. We are just throwing it. So if you take this waste cooking oil, waste tires, produce the carbon, and we use it as a catalyst to convert the oil into biodiesel. So you can actually make a gas, biodiesel. North Carolina is a really good renewable state. They have been doing a lot more. Tennessee has not been doing at all, but there are good opportunity. So the technology we developed at Oak Ridge, for example, our governor, so they have the pilot scale. So we can team up with all the state and also local with technology we developed at Oak Ridge. We worked with Wake Forest and Georgia Tech. So we are converting to waste. So this is the ultimate sustainability I can think of. So we are taking two waste extremes of cooking oil and the tires, converting into a real useful biodiesel. So that's a technology we are working on right now. And the other one, fuel cells, and the other thing is water desalination. So clean water is really, really important for the whole world. If you look at the West Coast, already California, they don't have enough water. You cannot water your plants every day. They have restrictions. You can water only 1 or 2 days your yards. So these are the things we already face it. So we need clean water. So we have used some of our technology to convert the salt water into a clean water. So there are different kinds of uses. So we are coming up in working with undergraduate interns, students working with me. So these are different forms of energy thing. So I'll touch on batteries, what they are, simple terms, so that you can understand. So let's talk about types of battery. So we have been using batteries every day. So first what I call is batteries are mainly they want to, if you take two material, they want to react. So the AA battery, AAA battery, We know those are primary batteries. Primary batteries means you have electrochemical one side of reaction, you cannot reverse it. And the secondary batteries are this lithium ion battery. That means you recharge. Every day we charge our phone. You can imagine if the phone battery dies, you are always going back and charging it. So it's very critical for our life. Without battery, we cannot survive right now. So all these batteries, we are using this carbon from this waste tire for the batteries. So what's happening is, think about battery, it's a 3-compartment system. Batteries means you have an anode, you have a positive electrode, negative electrode, and then electrolyte. So it's always 3-compartment is a battery. So if you talk about anode, that's where you have the oxidation, reduction. Remember, in science class, you are already studying addition of electrons is a reduction, removal of electrons is oxidation. So you are reducing and oxidizing ions. It's a real chemistry, simple chemistry. That's what we have. And the electrolyte is liquid electrolyte. Okay. So the reason, do you know why we are calling lithium ion batteries? Does anyone know? So you are mainly transporting lithium from cathode to anode, anode to cathode. That's what when you do charging, you are transporting. I have schematics. So the electrolyte is a liquid electrolyte. It's not electrically conducting, but ionically conducting. Imagine you have a 2 electrode, simple liquid, and that's what we have in a battery. I'll show you. So the other battery we know, lead acid battery. We have been using this battery for over a century now. So every day to start your car, the lead acid battery, that's what we have. And if you look at lead and lead dioxide, Pb is the lead dioxide, sulfuric acid, we always see some water, sometimes we pour, you can see the corrosion reaction, all those things. So the lead acid battery, you can get only in a single cell 2 volt. So you have a 6 cells in a lead acid battery, it's 12 volts. So if you imagine, if you want to run your electric car, hybrid car, you need really a high energy density battery. So that's what at Oak Ridge we are looking at different electrode materials. Can we do fast charging? And like 5-6 years ago, we developed a technology at Oak Ridge. We still have it. Imagine the cell phone takes an hour to charge a phone, and we have material, you can charge it in 3 minutes. Imagine you can charge your battery. We have the technology at Oak Ridge. I have already discovered. We have patents published. Only thing we need to scale it up to commercialize. We need a company to take it to the next level. So these are the things we are looking at. And the electric car, right now we are limited by distance. So when you single charge, you can go only 50 miles, 75 miles. Recently, Tesla, all these newer cars are coming up with a high energy storage. You can go for maybe 200 miles. So that's what we are doing. Still depending on energy. So what we do is, this is you are using every day's life. That's what we do as research. It's a really exciting place at Oak Ridge. Please make use of it. June 8th and 9th. 8th is the Bring Your Family Day. So if any of your relatives are working at Oak Ridge, that's a very good opportunity to visit Oak Ridge. And 9th is a community day, Saturday, June 9th. So that's another good opportunity. Please check websites and see how you can come and visit Oak Ridge. So you may be seeing some of this technology. We'll be volunteering in all these places, so you get to see. So one thing, energy density is how much voltage you can get it, and the capacity. How much electron you can store in a battery is the capacity, how many electrons you can store. So that's how when you multiply voltage times capacity is energy density. So in a lithium ion battery, what we have is, so you have a cathode, lithium containing oxide, and anode is the simple carbon. So this cathode material, almost all the materials were discovered by my mentor in Texas, John Goodenough. Lithium iron phosphate, lithium cobalt oxide, lithium manganese oxide. That's what we are using in all your batteries. So he discovered all that. So during the charging, what happens is the lithium ions coming from the cathode into the anode. During discharge, when you use the phone, lithium is coming back from the anode into the cathode. So the electrons transfer, go through the outside. It's a simple thing, 3 electrode system, 3 compartment. One is the anode, cathode. So when you do your charging, lithium ions are transporting. That's what we are doing. So we are trying to improve the density, all these things. And this is from 8th grade chemistry book. So this is the standard hydrogen potential. Imagine we always play with different things. You take potato, put steel and iron. You can always get any voltage out of all these things. Small battery, you can build your own thing. So we have like reduction potentials of different things. So you can, based on these reactions, you can take any of these metals, ions, and you can actually form a battery. So the lithium ion battery, it happens, what's happening is lithium is reduced, is giving 3 volt, and manganese 4 plus to 3 plus is giving 1 volt. So totally you can get 4 volt out of lithium ion battery. And the good thing about lithium ion batteries is there is no memory effect. You can use it in either cold or hot, different temperatures. You can do all these things. So flexible, we are depending on lithium ion battery. And fortunately, one of the electrodes we developed from the tires, you can use it thing. So I'm going to just show you the battery manufacturing process, how it's made. So the way it works is once you take the carbon, you can do a coating on a copper foil or aluminum foil. Aluminum foil is, we use aluminum foil and we coat it on the copper and aluminum, then punch it. You can make any size. It's very easy to make. So depending on your iPad size or a battery size, they go to the battery manufacturer, this is my size, and that's how it works. So let's see the small video, the one we have.
Rechargeable battery cells are manufactured in cylindrical or prismatic cells, as this animation illustrates. First, copper is rolled into a foil that serves as the current collector on the anode side. Aluminum is used on the cathode side. Next, the electrode is deposited onto the current collector foil. The anode is typically made of graphite and the cathode of lithium-containing oxides or phosphates. The electrode coating goes through a drying step in which unnecessary solvents are removed and the slurry-based coating is solidified. After drying, the 2 electrodes come together in a sandwich structure with 2 separators, shown in green, positioned in between. This flexible layer structure then goes through a winding process and forms what is called a jelly roll. For prismatic cells, these structures are cut and layered, flatly rolled, or Z-folded. Next, the jelly roll is packaged into a cylindrical container that resembles an oversized AA battery. Here you can see the internal structure consisting of the 2 current collectors with electrode and the 2 separators for avoiding a short circuit. Before sealing and crimping the container, the battery is filled with liquid electrolyte. It is critical that the electrolyte wets the separator and fills all pores, leaving no or minimal voids in the separator foam. 8 to 12 cells are packaged in a module. Then 8 to 12 modules are packaged with a battery management and cooling system. Such a battery pack can then be used in plug-in hybrid and all-electric vehicles. The same or very similar battery packs can be used for stationary storage to enable intermittent renewable energy sources such as wind and solar.
Yeah, so that's what we have. So you can see how the batteries are made. In Chattanooga, there is a small company. They have a manufacturing place where they actually make these kind of batteries. So you can actually look at some of those. So I'll be happy to answer any questions you have.
All right, we got a couple questions. So the first one
Yes.
is, when will the tire recycle technology become available to everyone nationwide?
So that's a good question. So the EPA is always after this. So they want to make sure whatever, when you heat it, something that's coming out, hazardous gas should be contained. And there is a company in South Carolina. So they are already making right now PRTI. So if you try Google, you can find the video. So they are making a small right now recycle. And I'll be meeting some of the investors in a couple of weeks with a potential possibility. So either in Roan State or one of our area, they are trying to build one. So
Wow.
I'm looking forward to that. Yes.
Okay. Another one is, what do you like most about your job?
The thing about is science. So you always really, because you feel top of the world, because we are doing whatever we do, you are actually using it, and I can already see the next 15 years, 20 years, what you and I will be using. So that's what we are looking for, future technology. That's the excitement, working with different kinds of students, people, and different background. That's what I'm excited about.
Okay. So in your opinion, what is the best type of battery?
So far, right now, lithium-ion battery is the best battery what we have. But we want to go even beyond lithium-ion. So we are looking at sodium is another battery looking at, because sodium is available in plenty. It's a seventh most abundant element, whereas lithium is very rare. So we consume more lithium-ion batteries than the rest of the world, and we have 3% domestic supply. So I have a project, we are looking at geothermal brine, where we want to separate lithium salts so that we can use for the battery. Because Elon Musk is building this big gigafactory in Nevada, so that's where they need lots of things. And they are bringing from Chile, Argentina, and Australia and China. That's where all these things, yes.
Okay. And last one, so does the lab have to have a company to release your research into the real world?
So that's a mechanism, because we are a government lab. So it's a research organization. So the way we do is we come up with the idea, we apply for a patent so that we protect the intellectual. If it is for defense, any of those, it will be classified. So we can also work in the unclassified manner. Then we can use this technology transfer office, where we can take this idea, either we can start our own company or you can work with the industry. So that's the model we have been working on, so that we can start, and we want to see more companies around Oak Ridge. That's what I would like to see.
All right. Thank you so much.
You're welcome.